Hey, so I want to do a quick screencast just to talk to you a little bit about experimental design prompts. So, yeah, at KIS, like all our science classes, one of the BLCs addresses experimental design. And certainly on the AP test that you'll take in May, there's a major FRQ that's going to have that in it. So let's just make sure we understand how to approach these prompts so that during the course of this year you don't lose points on your test. Let's just get going here. Okay, so here's the basic approach you want to take to an experimental design prompt that you get from me. And you'll get these from me like many times a week. Okay, so the basic approach to do is this. Okay, you want to read over the prompt and you want to figure out what is your independent variable. What is your dependent variable and what are your control variables? That's always your first thing you want to ask yourself, okay? So the independent variable is something that can change that you are going to make changes to. You have the agency to make choices about. If you can say, I'm going to change the mass or I'm going to change the force, okay, well then that's the independent variable. The dependent variable is something that you think is going to change because of what you did to the independent variable. You don't get to choose it, but it is going to be affected by what you did to the independent variable. So you're going to change the independent variable, by make the choice ahead of time, and you're going to see what happens to the dependent variable. Now, the control variable is a place where a lot of people I find get into trouble. A control variable is this. You have to ask yourself, are there other variables other than the independent variable that could affect the value of the dependent variable? All right. So let's say I'm doing an investigation where I'm going to change the angle of a track, and I want to know how that's going to affect the acceleration. Well, if I'm going to change this, and this is acceleration, I want to ask myself, is there anything else that could affect the acceleration? If there is, I need to keep it constant throughout the experiment. So a control variable is one that could also affect the dependent variable, but it's not what you're investigating. So you keep it constant so that any changes you see in the dependent variable is attributable to the independent variable. Okay? So here is the good news. In this class, almost always the independent and dependent variables are going to be present in the prompt. So what you do is you just read the prompt, and if I was you, I would just circle the independent and dependent variables, or at least circle the two. Let's just take a look at this, okay? So here's something that would be fairly emblematic of what you might get in my class. Students are asked to find the relationship between the distance traveled by a cart and the maximum velocity of the cart when it reaches the bottom of an incline. The students are given the following materials: a metal track that can be angled from 0 to 45 degrees, a wheeled cart, 4 metal bars of 125 grams each, a meter stick, and a hand timer. That's pretty typical stuff that you get from me, okay? So step one, you want to identify what are the two variables that are present in this prompt. Specifically, what two variables were mentioned? Well, the two variables that were mentioned were the distance traveled by the cart and the maximum velocity at the bottom of the incline. Those are the two variables. One of those is going to be independent and one of those is going to be your dependent. So the next thing you want to do is you want to figure out which one of these two is the independent variable. And that's the one that you have the agency to make changes to and to make decisions about ahead of time. Okay, so in this case, what I could change is I could change the distance traveled is what I could change, right? The other variable that was listed then, that's going to be my dependent variable. So now I know the basic setup for my investigation. I'm going to change the distance of the cart, and I'm going to figure out what its maximum velocity is when it gets above. Now notice something. In most of the cases in AP Physics 1, you are not going to be able to directly measure both of these. I mean, like, never going to happen. You're always going to have to use your understanding of physics to figure out how to give a value to these. You're going to measure certain things, but then you're going to have to, the variable in question often has to be calculated somehow. And the writers of the College Board questions are going to ask you to specify how is it you're determining this value from the measurements that you took. Okay, so decide how you're going to measure the independent and dependent variables and how you're going to implement changes to the independent variable, right? So let's just first talk about the independent variable, okay? So here's what I'm going to do. I'm just going to, this is really simple in this case. It isn't always this way. I'm just going to place that cart at different positions along the ramp, okay? And how am I going to know what that is? Well, I'm going to use a meter stick. Again, it's not always going to be that easy, but you need to be able to articulate it. There's going to be check boxes on your AP test where you're going to say, like, okay, this is what I'm changing, and here's how I'm changing it. Well, therefore, what's my dependent variable? Now, this one's going to be a little bit tricky. I can't directly measure the velocity. I don't have a velocityometer here. So what I'm going to do is this. I'm going to have to use a hand timer, because I was given one. to find out how long it takes to reach the bottom of the track. Then, like we talked in our last class, I'm going to say, well, the average velocity can be found by taking the total distance traveled divided by the total time of travel. And now that I know what the average velocity is, I can use this equation and say, well, the average velocity is equal to the final velocity minus the initial velocity, which was 0, divided by 2. And from that, I can find the final velocity. And you need to be able to articulate that on my test and on an AP test. Now, let's just talk about controlled variables. So a controlled variable basically says it's any variable other than the independent variable that could have an influence on the magnitude of the dependent variable. So what else could cause the dependent variable to have different values? All right. So in this case, you think like, well, you're going to learn in this case like mass wouldn't change anything, it turns out, but we haven't gotten there yet. But in this case, what definitely could? Well, so in this case, definitely since I've told it's an angled ramp that can go from 0 to 45, I need to keep it at one angle the whole time. And I specify, if I'm asked to describe the experiment, I just specify what I'm going to do it at. So, and you often have to justify why it's going to be controlled. So my justification would be, well, if I change the angle of the track between trials, I'm going to change the acceleration of the cart. And if I change the acceleration of the cart, that's going to have an effect on the final velocity. And the only thing I want to affect final velocity is my independent variable, which in this case was the distance it traveled. All right, now the next thing I have to decide which materials to use. Now listen, I'm a stinker. I'm always, and I mean always, on every single test and often on your daily activities, I'm going to give you more materials than you need to use to answer the question. So you've got to be a grown-up here and say, well, what do I actually need to use, okay? So don't change values just because you can. All right, Mr. Simpson gave me this stuff. I need to change it. That is not how a scientist thinks, okay? So you just had to say, I'm only going to make changes to the independent variable. That's it. And then I'm going to see what the dependent variable is. So in this case, those 4 metal bars that would allow me to change the mass of the cart, that's not what the experiment is about. The experiment has nothing to do with changing the mass of the cart. It has to do with changing the distance. Therefore, I'm just going to ignore that. Like, I'm just going to not use that in my investigation at all. And that brings us to the last part. And this is the hardest part. And I don't often ask you to do this. And to be honest, College Board often doesn't, but sometimes they do. And that is, you may be asked to describe how to go about, describe how you would conduct this experiment. So here's my advice to you. First of all, use a bulleted list. It's definitely way easier for the reader, me, or the person at College Board to do. You always want to describe in detail how you are going to change and measure your independent variable. And then you want to describe it with enough specificity how you are going to measure your dependent variable. All right, then you want to indicate which variables need to be controlled and how you're going to implement those controls. In this case, I'm going to keep the angle of track constant. Indicate how many times the independent variable is going to be changed. And by the way, the answer is at least 5 times. Okay, but the nice thing is there, you can say repeat the procedures up above 5 more times, change the independent variable a little bit each time. Okay, and now this last one is pretty important, and that is to indicate how you're going to reduce measurement errors. They are going to ask you this on the AP test. It's a really easy answer. I'm going to do multiple trials, and I'm going to take an average. And if you just say that, you're good to go. I mean, there's other answers you could have, obviously, but this is the safe bet to use. Hey, listen, thanks for watching this. You're going to love doing these experiments, and I just want you to have success. So hopefully you watch this screencast, and you know what to do in class and on our tests. See ya.